So we are looking at the principles followed when calculating oxidation states. Members, they are simple and we should know them. When we fail to understand them, we shall not be able to calculate for the oxidation states. Any atom or molecule that is not combined with any other thing, with any other atom or another molecule, is always having an oxidation state of 0. So what I mean, the uncombined atoms or molecules have an oxidation state or number of 0. For example, if they give you what is the oxidation state of calcium, and they write like that. In this case, calcium is existing as an uncombined atom. So its oxidation state will be as 0. For example, when oxygen is written like this, it is now in its uncombined state or form. Here, its oxidation state or number is 0. So this one is a molecule, a diatomic molecule. It is made up of 2 atoms. Yes, it is not combined with anything else. They are 2 similar atoms. So the oxidation state of this molecule will be as 0. So this is what the first principle means. We shall consider it greatly in our calculations. 2, the charge of any ion is taken as the oxidation state the charge of any ion is always going to be its oxidation state. For example, if we have a sodium ion, we know it is written like this. So this sodium ion is charged to +1. So its oxidation state will be +1. We take its charge as its oxidation state. Let's look at another example. Let's talk of a sulfate ion. We write it like this. So the oxidation state of this sulfate ion will be a -2 because it has a charge of -2. So the charge on an ion becomes its oxidation state. The third principle we shall look at that any oxide any oxide in any substance in bracket the combined oxygen whenever we shall find oxygen but combined with anything else, it will always possess an oxidation state of -2. But with an oxidation state of -1 if it is in a peroxide form. If it is a peroxide. So the oxides, where oxygen is used as an oxide in a combined state, it will be with an oxidation state of -2. But if they give you anything, for example, sodium peroxide, and you want to know the oxidation state of the peroxide, each peroxide molecule, atom, has an oxidation state of 1. For that, the oxygen will be with an oxidation state of -1. So, for example, if in potassium oxide, we are going to find that here oxygen has an oxidation state of -2, which will not be the case in sodium peroxide. Each of these peroxide atoms will carry an oxidation state of -1. So we should note this. So we are getting -2 because oxygen needs 2 electrons, has to lose 2 electrons, and has to gain 2 electrons during bonding. That's why we are giving it this oxidation state. We are going to look at how to calculate. Here, to get the oxidation state of oxygen, we shall get the -1, which is the weight of each peroxide atom, multiplied by the number of peroxide atoms we have here. There are 2. So it will end up with a -2 as the oxidation state. But it may not be the case with oxygen, not a peroxide. For example, in aluminium oxide, the oxidation state of this one remains -2 if it is an oxide or oxygen, not a peroxide in a combined state. So the oxidation state of this oxygen alone will be calculated as the -2, which are the number of electrons oxygen needs to gain to become stable, multiplied by the number of atoms of oxygen in the compound or substance, which is a 3, giving us a -6 as the oxidation state for this oxygen in aluminium oxide. So you should know this. Why did we use -1? Because here oxygen is used as a peroxide. So you should know that rule number 3. It usually confuses people. Rule number 4. Rule number 4. The sum of all oxidation states in a compound is always at 0. For example, if we happen to add up all the oxidation states of the individual atoms in this compound, calcium carbonate, we shall always get a what? A 0. So this is going to be crucial in our calculations. Let us now think. Calcium needs 2 electrons. Needs to lose 2 electrons to become stable. We know it has a valence of 2. Being a metal, it will lose electrons. So we shall have a positive 2 for calcium times the number of calcium atoms in this, it is a 1. Then plus, because they told us the sum. The carbon needs to share 4 electrons times the number of atoms. Why sharing? Because carbon is a metalloid, we know that, and metalloids bond by sharing electrons. The number of electrons, the number of atoms of carbon in this compound is 1. And plus, we want to prove is it 0? You can look for many other examples. We shall find that the sum will be 0. We said oxygen in a combined state, not as a peroxide, is a negative. It has an oxidation state of -2 times the number of atoms of oxygen in the compound, which is a 3. So we shall have a +2 plus a +4 plus a -6. So this gives us a 2 plus a 4 minus what? This one adds up to +6 minus 6, giving us a 0. That is why the oxidation state of all, we shall find that all compounds we shall rate shall have a sum of the individual oxidation states of the atoms in it as 0. So we should know this rule and the way we've stated it. And lastly, or rule principle number 5, the oxidation states of all atoms in a compound are the number of electrons on the outermost energy levels needed to be lost or to be gained or shared during bonding. I repeat for you. The oxidation state of each of the atoms in a compound is the number of electrons on the outermost energy level the atom needs to gain, lose, or to share so as to get a stable state or structure. For example, for sodium needs to lose 1 electron. So its oxidation state is +1. The ones that lose are positively charged. The ones that gain, they have negative oxidation states. For example, chlorine, the chloride ends during bonding, they need to lose electrons. So the oxidation state of chlorine in any compound will be a -1 because it bonds by gaining electrons. So the metalloids like calcium, carbon and silicon, for them share electrons with others, but we usually give them an oxidation state of +4 because they belong to group 4 and they have 4 electrons on the outermost energy level, which they usually like to share with others so as to bond. I'm taught online. Don't forget to comment. So in our next video, we are going to come back with calculations, real calculations of oxidation states of different compounds, different atoms in compounds, and the oxidation states of different uh, atoms in ions. We are going to look at it so that we can be better in these calculations. Let's meet.